Welcome to Solving Systems of Linear Equations by Elimination. This is one of two algebraic methods that we will be using. You will need to be able to use them both when indicated. In some instances, for example, when the coefficients are rational numbers as well as word problems, you'll be able to use the method of your choice. And so the elimination method means that we will eliminate either x or y, and there isn't one specific way that you have to do it. It'll work both ways, so you can eliminate x's or y's. Sometimes, though, there is a slightly easier way to do it. However, it's not necessary that you choose the easier method. So what happens is we need to eliminate either the x's or the y's, and we do this by looking for the same or the opposite numerical coefficients. So that means we each want them to have the exact same number to the left of them, or the same but opposite. And so this first one is set up nicely for you. You can see that we have the y's have coefficients of -3 and 3. And so what that means is we can eliminate the y's right away. In order to end up with 0 y's, will we have to add or subtract those two equations? Well, in order to get a 0y out of -3y and 3y, we are going to have to add them because -3 plus 3 is 0. So what we're going to do here right away is we're going to add these two equations. So 2x plus 5x is 7x. We've eliminated the y, so we have 0y. And when we add, we end up with 42. And now we're just dealing with a simple linear equation. So we're going to solve for x. We'll divide both sides by 7, and we'll end up with x equals 6. Now remember that in order to solve, we need a value for x and a value for y. So we take that value for x, and we can substitute it into any one of those two equations. And we can do that because we know that the value that we get for x and the value that we get for y has to work in both equations. So it doesn't matter which one you pick. So I'm going to pick the first one, and I'm going to substitute 6 in place of x, and then I'm going to solve for y. And just like when we solved by graphing, I have my x value and my y value, so I need my solution set. So if we were to solve this one by the graphing method, those two lines would intersect at 6 and -1. Now, if you look at the equations here, a little bit more complicated to graph, right? Because we're not going to have a nice slope, not going to have a nice y-intercept, and so that's why the elimination method comes in handy. Second one, and there's the little hint over there, just trying to make sure this lines up. So here now we have our x's. We're going to eliminate x's because both of the coefficients are 2. And so you can do this one of two ways. First of all, if we just take a look at it, in order to eliminate the x's, are we going to have to add or subtract them? Well, in order to get 0x from 2x and 2x, we'll have to subtract. Now, for some students, that might be a little bit tricky. You always have the option, if you prefer to add, is you can multiply everything by -1 so that you turn one of them into the opposite. I'm going to do it by subtracting, and I'll just show you why. So if we subtract those, we get 0 x's, but here's what we have to make sure. You have to make sure that you don't subtract the x's and add the rest of them, right? Because -4 minus -5 is 1, right? And 10 minus 12 is -2. That worked out quite nicely for us, didn't it? Now we're going to do the same thing we did with the first one. Take any one of those equations, substitute the -2 in for y, and solve, and then we write our solution set. And here's where it starts to get a little bit more interesting. So now we don't have any coefficients that are identical, which means we're just going to have to do an extra step. And so we could do this one of two ways. What coefficient would we need to use for x's? The smallest one that we can use would be a 6. And we end up with that by going 2 times 3 is 6. Okay, so in order to make them both a 6, I have to multiply this one by 3 and this one by 2. If I was going to do the y's, eliminate the y's, I would look for a numerical coefficient of 15, which means I'd multiply this one by 5 and this one by 3. And there is no better way to do it. So normally what I do is I do that, right? So when we multiply one side, we have to multiply the other. So 6y plus 9y equals 12. And you want to make sure that you don't forget to multiply that. Now I've got my numerical coefficients are the same, so I could subtract those equations. 9 minus negative 10 is 19. Y equals 2. And I always recommend substituting it back into the original equation, just in case you made a mistake with one of these. 2 x plus 3 times 2 x equals negative 1. So then we have that solution set, and then the last one. And just so you know, there's a set of steps over here, and I'll read them out while I'm solving this one. So this one's not going to be quite as nice answer-wise, so just an introduction of the fact that our answers need to be rational, not integers. So first of all, we need to choose which variable we need to eliminate. Now here's an example where there's a slightly easier way we can do this, so it'll be one less step if we eliminate the x's over the y's, and that's because 9 will be the coefficient we use, so we'll only have to multiply this equation by 3. If I eliminate the y's, I'll have to multiply the top one by 2 and the bottom one by 5. However, it doesn't matter. So I'm going to multiply this one by 3. Okay, and now you can leave this one where it is, but I think what I'll do, and I usually do this, I'll bring it down. And then 9x plus 30y equals 9. So now I'm ready to subtract my equations. Negative 55y equals negative 22. So here's where you can see it's not going to work out too nicely, but that's okay. We're used to fractions. So y will equal negative 22 over negative 55, which simplifies to 2/5. Then we'll go back to the original equation. 25 times 2/5 equals negative 13. Get to use our fractions again. Minus 10. 9x equals negative 3, and x equals negative 1/3. So there's an example where the values aren't quite as nice. So we definitely wouldn't want to graph this system because, of course, those two lines will meet at negative 1/3 and 2/5, which is a lot harder to check. So we chose the variable we wanted to eliminate. Then we multiplied either one or both equations by a constant, solved for the first variable, substituted that value into one of the original equations to solve for the other variable, solution set, and then of course you can either check your answers with the answer key or do a verification if you want to ensure that you have the right solution. And that's the end.